Welcome to this video. In today's video, we would like to talk about a coding exercise. I think that it's better to learn the concepts when they're applied in exercises so we can feel the practicality of these coding exercises and the concepts that we're going to learn. Here, we would like to create a simple line plot for the function y equals x to the power of 2 for x values from -10 to 10. And we would like to have a customized line color of red. Okay. Now for plotting in Python, we need to import Matplotlib library. So in order to import Matplotlib library, we're going to simply call it here. And also for numerical operations, we need to have the NumPy library. Therefore, we are also importing the NumPy library here. Now we mentioned that we would like to have for x values from from -10 to 10. In order to generate the values for x, we are going to use the np line space function. This function requires 3 arguments, okay? So the starting point, the ending point, and the number of points that we would like to be evenly spaced, okay? Now this np line space function is going to have the start point to be -10, the stop point to be 10, or let's say the ending point, and then it is going to generate an array of evenly spaced numbers. So this is the third argument. So when we are having, for example, 100 points, it is smoothly having the curve when plotted, but if we are having lower number of, for example, points in our array, we are going to see that it's not very much smooth. We are going to test it now in a few minutes. So this np.line space function, we used it to generate the x values for us, the starting point, the ending point, and the number of points in that array, and it is equal to our x. Now we need to have the y function here because y equals x to the power of 2. We need to have it. In order to compute y value for the function, for this function, we're going to have y equals x to the power of 2. So when we want to have the power in Python, when we want to have a number to the power of 2, for example, we are going to use star star. Okay. For example, 2 star star 2 means that 2 to the power of 2. Okay. It means that 2 multiplied by 2. So when we want to show the power in Python, we are going to use star star. So 2 to the power of 2 means 2 multiplied by 2, so their output will be 4. This was just an example, but in order to compute the value of y for this function, we first need to implement it. So it is the implementation of y equals x to the power of 2. Now we calculated, we generated the x values, and we also computed the y values. Now it's the time for plotting our plot. Now, in order to plot our plot, we need to use the plt.plot function. This is a function that we can use for a custom color because we mentioned that here we would like to have a customized line color of red. So here, this function plt.plot is used to create a two-dimensional plot in Matplotlib library. Okay. Basically here, x is the horizontal values and y is the vertical values, and we are simply saying color equals red. So we would like to have the color red. Now the plot, we are creating the plot. We use the plt.plot function to customize the color and create the x and y axis. Now we need to label the axis and also the title. In order to label, we can have the plt.x label. So we are going to have the horizontal label, which is x-axis. And then plt.y label, we can call it y-axis. And the title of our figure, we want it to be this. This is the title parabola, and this is the title of our plot. And then we use the plt.show to show what has been done. So when I run this code, first of all, we see that the plot is in red. So let me put this a bit lower. So here we see that the plot is firstly red because we chose it to be red here. Okay. If I want a plot that is blue, I can have blue here, for example. When I run the code one more time, we see that the color has changed. So we can choose the color quite easily. Then we see that the title is parabola. This is exactly what we chose here. We can change to something else, for example, function. Now, if I run the code, we see function is the title of the figure here. Then we are having the x-axis and y-axis. We can change its title as well. For example, we can say it's time and it's not x-axis. For example, if the unit is time, we can write it down time here. We can change this one accordingly. So it's our choice. So I get back to the x-axis because it's easier to understand here. And this is the two-dimensional line chart that we see here that is shown in color blue. And you see that for values of x, we are having from -10 to 10 that we are having it here. As you see, among all this line, there are 100 points of x values to have a smooth shape. But if I change this 50 to this 100 to 50, let us compare. So you see that now the figure is a bit less smooth, but it's not very much identical. So if I put to number 10, for example, we should be able to see the difference. As you see it here, yeah, it's not that much smooth. You see it's some parts are sharper. You see it here? So it's not a good idea to have lower number of points. It's better to have sufficient number of points in order to keep the shape very smooth. So this was how actually we could create a line plot here and illustrate it simply here. And we could have, for example, y equals to x to the power of 3. So if I run the code, we see that the shape changes because now we are changing the y function. The y function was y equals x to the power of 2. Now it's x to the power of 3. So the shape is changing. But what if I do, for example, for x to the power of 4, for example? When I run the code, we see somehow the similar shape, but this part, the down part, is a bit more flat as compared to x to the power of 2. So you see the flat here, but when I have x to the power of 2, for example, we see that it's not that flat, it's more curvy in the downside. So let me also put the color red here and I run the code one more time. So this is how actually we can have a simple line plot for function y equals x to the power of 2 for values of x between -10 and 10, and we had a red color line. So in this video, first of all, we learned that if we want to use the Matplotlib library and do some numerical operations, it's good to import the Matplotlib library and NumPy. Then the second lesson of this video was that we learned about np.linspace, so we can generate values for x between the start point and end point and the number of points that we want to have in our array that are generated with evenly spaced. Also, we learned how to implement the function y equals x to the power of 2. So to the power of 2, we learned that if we want to do it in Python, we need to have star star, okay? Then we learned that in order to have our line plot in two-dimensional, we can have the plt.plot function and then simply contain the horizontal values and the vertical values and also choose the color. And this is how we can label the horizontal axis, vertical axis, and also the title of the plot. This is how we can label it. And finally, to display the plot, we learn to display the plot. Sorry, we can use plt dot show function to have the figure being shown here. Thank you for watching. Hi, welcome back. In today's video, we're going to have a coding exercise to use different line styles. We would like to plot two lines on the same graph. So here we see that this is the first function, y equals 2 multiplied by x plus 1. And then here we are having y equals minus x plus 5. We would like to plot these two functions. And for the first one, we are willing to use a dashed line. And for the second one, we are willing to use a dotted line. Okay, so two different line styles. First of all, we import the necessary libraries. Then we are going to again use the np.linspace function. The starting point is minus 5, the ending point is 5, and we are going to have 50 points on this line for x. Then we need to, now that we generated the values for x, we need to generate values for y. So because we are having two y functions, we are going to define them separately. So we are going to have y1 and y2. So y1 is the first function, which is 2 multiplied by x plus 1, and y2 equals minus x plus 5. So this is exactly like the two functions that we are having here. Okay, now we generated the values for x and we defined our two functions. Now we need to plot these two functions with different line styles. In order to do that, we use the plt.plot function. And in parentheses, we have the horizontal line and the vertical line, so x and y1, because it's for the first function. Now, in order to have a dashed line, we write down line style equals, and then in quote, we are having two dashes, okay? With a comma, we separate it by a label. So we want to label it because we are drawing two plots in one figure. We need to label it. So this is the label saying that, okay, this line plot is for this function. Y equals 2 multiplied by x plus 1. Then we need to have the plot for the second function, but this time it's the dotted line. In order to do that, we again use the plt.plot function. We have x, and we are this time having y2. In order to change the line style, we are going to have line style, and in quote, we are having colon instead of dashed here, because there we were looking for dashed line. Here we are looking for a dotted line. So colon, and we separate it by a comma to have the label as well. So the label is y equals minus 5 plus minus x plus 5, sorry. Then we need to also label our figure. So the x-axis, the y-axis, and the title of the plot, we are labeling them here. We are also showing the legend to differentiate the lines, and then finally we show the plot. So when I run this code, we see here is our plot. So first of all, this is the legend. This is the legend for the labeled lines. So here we had the labels y equals 2x plus 1, y equals minus x plus 5, y equals 2x plus 1, y equals minus x plus 5. So these are the labels that we defined, but we are going to show them using the legend function. So if I simply comment this one and run the code one more time, we see that it disappears. So even if we label the lines, we need to include the legend function in order to have access, in order to have the legend being printed in the output here as you see it. Okay, so based on this legend, we see that the blue dashed line is having the y equals 2x plus 1, and then the dotted line is for y equals minus x plus 5. So this is how we can have the functions being shown in lines but different styles. And also we see that the generated values for x is from minus 5 to 5. So we see that from minus 5 to 5, we are having the x axis here, and we are uniformly having, for example, 50 points there. So if I put it to 100, we see that because there is no curve, it's not that much tangible to see when it's 100 or 50. So we keep it with 50 because at some point some number is enough. So now here we see that the lines are plotted here. Then we talk about the labels. So we see that the x label is x-axis, that is shown here. The y-axis is again here and here in the figure, and also we are having the title of the figure here. So this was a good example in order to practice to have a dashed line and a dotted line rather than a simple line being shown in the output. Thank you for watching. Hi, welcome back. In today's video, we are going to have multiple lines with different customization. So we are going to plot the following functions. These three functions. We want to have y equals to x to the power of 3. So let me put the power, okay, to the power of 3. And we would like to have a solid line, a red line with square markers. Then we would like to have another line, which is this function, y equals to, in parentheses, we have minus 2 multiplied by x to the power of 2. And we close the parentheses, plus 5. We would like to have a purple dashed line with triangle marker for this one. And finally, we are having a function y equals 3x minus 4, which is an orange dotted line with cross markers. In order to plot these three customized lines, we are going to import our libraries. Then we are going to have the generation for x values from minus 3 to 3. We are going to have 30 points. Okay. And we are going to use the linspace function from the NumPy library and assign it to x. Then it's the time for us to define our functions. So because we are having three functions, we are going to label them y1, y2, and y3. We have x to the power of 3, which is this one. Then we are having y2, which is negative 2 multiplied by x to the power of 2 plus 5. And finally, y3 equals 3x minus 4. Okay, so these are the implementation of our three functions. After that, we need to plot these functions. So we plot the first function x and y1,
And we said that we want a solid line, so we are having only one dash. The marker should be square, so the marker is S, and the color should be red, so the color is red, and we are going to label the function as well. Then we are having the second plot, X and Y2. The line style is 2 dashes because we wanted to have dashed line, and because we wanted to have a purple one, we are having the purple color, and triangle marker is there, so the triangle marker is like this, and then we are having the label. Finally, for the third function, we are having x, y3, because x is the horizontal line and y3 is the vertical line, so we are having the dotted line. So dotted line, we use colon. The marker, because we want cross markers, we are looking for X here. It should be orange, so we are having the color orange, and then we label it as the function is. Okay. After that, we are going to label our figure. So x-axis, y-axis, and multiple custom styled lines. So this is the title. Because we are having the labels here, we need to use the legend function in order to have it here. Okay, so if I comment this legend function as we see here, this will disappear. But this is now it's hard to see what is what. Okay, so this legend function is very helpful to understand the labeling. So you see that the square marker with the red line is for this function, for example. So I know, okay, red is my first function, for example. And after that, we simply use the show function to plot the figure. Here is my figure. This is the x-axis, y-axis, the title. This is the legend. And these are our figures. And as we see, the first one is red. X starts from -3 to 3. And it has 30 points on each of these lines. There are 30 points. And we see that it's the representation of x to the power of 3. Then we are having the second function here, which is shown by triangle purple. We see it is shown here. And then finally, we are having the third function with the cross marker. So we see it here also. Thank you for watching. Hello, welcome back. In today's video, we are going to work about creating a basic scatter plot. First of all, we are going to import the necessary libraries. So this library, Matplotlib library, is for plotting, and NumPy is for numerical computation. Because we want to just create a basic scatter plot and we don't have any numbers at hand right now in this coding exercise, we are going to generate randomly some numbers for us, and we're going to learn how to generate numbers actually. So here, in order to generate numbers, we are going to set the random seed to 50, ensuring reproducibility of random numbers generated by NumPy. So random.seed, and then we are going to use an arbitrary number there. It can be 40, it can be 50, it can be 60. It's your choice. It has no impact now on our example, therefore I just choose it to be 42. But this function is very important to be called, because now that I have this function, if I run the code several times, I'm going to get the same result. So it's going to seed the it is going to set the random seed for me. So every time that I'm going to rerun the program, it is going to have the same output. We are going to test it. After that, we are going to generate values for x and y. So we are going to have x and y coordinates, and we're going to again use the rand instead of random seed. We're going to have random rand number 50, so it is going to generate 50 numbers between 0 and 1. Then we are going to use random.rand function to have 50 numbers again for y. And basically, we are going to simply call the scatter function,
and put the X to be the horizontal axis and Y to be the vertical axis. When I run this code using this function, we are going to display the output. So here is my output. You see everything is between 0 and 1 and 0 and 1 here. So all the data that we generated is between 0 and 1. So 50 numbers for X coordinates and 50 numbers for Y coordinates, and we are here having the output of X and Y. Now, when I run the code one more time, you see that the figure does not change. And for example, this dot there, it stays there, you see? However, if I remove this function, a random seed that sets the random seed for me, now that I have this result, if I run the code one more time, we see that the figure is totally new. When I run the code, it's totally new. Another new figure, another new figure. So this function helps me to have one-time generation and then use it for the rest of the code execution. Okay, so now if I run the code one more time, we see that no, okay, everything is staying the same. This function helps to set the random seed to a specific number, and then whenever we rerun the code, we are going to see the same result. However, if we don't want to see the same result, we can comment this part, and as I showed you, you can have different results. Basically, in this video, we learned that we can generate random numbers between 0 and 1 using the random.rand function from the NumPy library. And also, we learned that it's important if we want to have one result for each run, we need to have the random seed function in order to set the random seed to a specific number, an arbitrary number. We can choose it, it's not important. So ensuring reproducibility of random numbers generated by NumPy. And also we learned that when we want to plot a scatter plot, we need to call the scatter keyword here. A scatter keyword needs to be there. So a scatter function will be called, and then we display the plot using the show function. Thank you for watching. Hi, welcome back. In today's video, we are going to discuss another scatter plot. Here, again, we are importing the necessary libraries, and we are going to simply have X and Y being generated randomly without having the random seed. So every time that I run, we are going to have a new figure. So you see, when I run, I have a new figure each time because we didn't set the seed here in the beginning. If we wanted to have that, we needed to have random dot seed and a number, for example, 50. If I uncomment this part, we are going to have the same figure whenever I run the code. But because I don't have this one and I'm directly using the random generation numbers for X and Y, we see that every time that I run the code, we are having a new figure. Then the second thing that we're going to learn in this video is the fact that we can work with the size of our figure. So this is the size of the figure. So we can have the figure function, okay? And in parentheses, we write down the fig size equals, and then the length and width of the figure is entered there. For example, this is the length and width of my figure. Now it's 10 by 5. If I write down 2 by 1, for example, you see that it will become very small. You see? But if I have 20 by 10, for example, it will be very large. You see? So this way you can adjust the size that you want for your figure using the figure function, and the fig size keyword equals the length and the width. So here is how I'm defining the figure size. Then I'm generating the random numbers for X and Y. And now I would like to plot the scatter plot. We use the scatter keyword. We are having X for the horizontal axis, Y for the vertical axis. Then we can modify the marker and the size of the marker.
the marker type, let's say, the size of the marker, and the color. Here, the marker is now O, which is a circular, as we discussed before. The size is 100, and the color is B, which is blue. Here are different markers that we can use. These are just examples and different colors. So the marker is O now. We can have a marker S. We discussed this before in the line plot. You see S, it's here. We can have D, for example. You see it's here. And we can have a triangle like this. So it depends on whatever we want. We can have V, star, and X as well. So I'm going to use V, for example, here. So when I have V, we see that it looks like this. And then we can have the marker size. So it's 100. We can have like 80, for example, if we want. When I run the code, you see they're a bit smaller. So I put, for example, 20. I run the code, you see that it's much smaller now. And here is the color that we can have. For example, B is blue. And if I put, for example, G, it will change the color to green. So you see that now it's green. You can also write down green here. You can also write down the full name of the color, for example, red. So it's red. Either you can use the keywords or you can have the full color being written there. So in this lecture, first of all, we learned about the size of the figure so we can modify the size. And then we learned about different marker types when we are plotting, the scatter plot. We learned about the marker size and also we learned about the color modification. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to plot a scatter plot that is 3D, so three-dimensional scatter plot. Here we are generating 3 dimensions like X, Y, and Z. So Z is for the third dimension. We are generating 50 numbers between 0 and 1. Then here we are having the size of the figure. Here is the size of the figure. We are saying 8 inches by 6 inches. And basically here we are just adding a subplot function and tell the Matplotlib library that we are going to have a 3D function. A 3D scatter plot. Then we are having the scatter function here with the AX prefix. So AX dot scatter. Then we are having the 3 dimensions. So x-axis, y-axis, and z-axis with each point having the size of 100. And C, which is the color, equals Z equals Z, and Y we are equaling to Z because previously we learned that if we want to have unique colors for each point, we need to have 50 numbers that are generated randomly, and then we use that to assign it to color map, and the color map will assign a unique color to each point that is randomly generated. So here we could also do that, but instead of that, we are simply assigning the color to be equal to the numbers generated for the Z that are also random. And then we are going to use those values in the color map, and we are going to use the cool warm color, and the alpha, which is the transparency level, is 0.7. And finally we are labeling our axis here. Okay, so when I run this code, we see that here we are seeing a 3-dimensional figure of our scatter plot, which is very attractive. And we see that for the X axis, for the Y axis, and for the Z axis, we are having numbers between 0 and 1. And as you see, the colors are unique, so they are on a scale bar. So we are having the cool warm color map.
So the values that are assigned for the color are used in the color map to generate each point a unique color using the cool warm color map. So here we see that the figure is much nicer when we are having it in 3D. So in case that you're looking for a 3D figure, this video is for you. So you can simply use the add subplot function to tell the matplot that you're looking for a three-dimensional figure and assign it to ax, and then use that ax to call the scatter function and label the axis. Thank you for watching.
Hi, welcome back. In today's video, we would like to talk about bar charts. Here, first of all, we are importing the necessary libraries. In order to have bar charts, we need categories and values. So here I'm labeling for my bar chart categories. For example, labels for the x-axis categories A, B, C, and D, and E. And also we need to have values for each category. For example, the height of the bar is the y-axis values. And here for the category A, I'm going to have the value 10. For B, I'm going to have 20. For C, I'm going to have 15. For D, I'm going to have 30. And for E, I'm going to have 25. So these are the basics that I need to plot a bar chart. Then here is how we can have the size of my figure. For example, here I'm having 6 inches by 4 inches, and we can modify it. We can, for example, have 8 inches by 6 inches. And the first number is the wide, and the second number is how tall our figure is. In order to plot the figure, we use the bar function. Then we have the category as the x-axis, values as the y-axis, and then the color. For example, here I choose to have sky blue. We have the edge color and line width. And finally, we are having here the title. For example, here I'm saying basic bar chart example. We are having the font size. We are having the font weight. So I want to have a title which is bold. Then we are having the label for the x-axis, which is categories, and we choose the font size. Then we are having a label for the y-axis, which is values, and we are having a font size, sorry. And finally, we are displaying the chart. So when I run this code, we are having this chart. So the x-axis is categories, the y-axis is values, and this is the title of my figure, basic bar chart, and the font is larger as you can compare with this as compared to this one. It's larger, and also it's bold. You see that it's bold. This one and this one, both of them, they're not bold. But how we draw that? So we said that we need categories and values. So on x-axis we are having the categories from A to E, and on y-axis we are having the values. For example, we mentioned for category A we are having the value 10. So this is category A, value 10. Category B, value 20. Category B, value 20. Category C, value 15 here. Category D, value 30. And category E, value 25. So these are the corresponding values to our categories. And one thing to mention here is that we use the bar function, x-axis, y-axis, then the color, and we are having the edge color. You see that there are edges here. So this is black. I can have it to be red so it's more identical, for example, you see. So you can choose this color as well. This is black, and you can discuss the line width. So the edge width is 1.5 now. It can be 4, for example. So you see that it's thicker now. So it depends on what we are looking for, but we can modify this as well. So in this video, first of all, we learned about bar charts and how to plot them, that we need categories and values, and then we need to have, for example, the categories and values to be x-axis and y-axis. We learned about the edge color and the line width, and also we learned how to make the title of our figure to be bold here. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about grouped bar charts. Here is my figure. So we are having grouped bar charts. So we are for A, we are having 2 bars. For B, we are having 2 bars. For each of them, we are having 2 bars, and we are having 2 datasets, dataset 1 and dataset 2. So dataset 1 is the blue bars, dataset 2 is the, let's say, the orange bars. Okay, so but how can we do that? It's very easy. We can have the categories. It's shared because we are having, for example, 2 bars for category A, 2 bars for category B. So it's shared. We can have A, B, C, D, and E. But each category has different, each dataset has different values. For example, in the dataset 1, for the category A, dataset 1, we are having the value 10. But for the same category in the dataset 2, we are having the value 5 here, sorry. So for example, for category B, we are having 2 datasets. One value is 20, one value is 15. So exactly here, the value 1 for category A, for categories, for A, B, C, D, E, and value 2 for these categories. So for example, A, if in value 1 is dataset 1, it's 10, but in the dataset 2, it's 5. So A for dataset 1, which is the blue, is 10. For dataset 2, which is orange, is 5. So we are having 1 categories and we are having 2 datasets. Okay. Now we need to have our X. So first of all, here, this part, the len function, and inside parentheses, we are having the categories, is going to return the number of categories for us. Okay, so the number of categories, which is 5. And we are going to have the number of categories, and then this part, the whole part, is going to generate an array from 0 to 4 with indices from 0 to 4 for 5 elements, which assigns a unique number index to each category. Okay, so we are going to have unique numeric index to each category A, B, C, D, and E. So this is what is going to happen here. Okay, then we are having the width of our bars, which is 0.3. So you see the width is 0.3 now, 0.3. So we can change it to what we want. We can have 0.2, for example. It's changing. We can have 0.1. We see that it's like this. We can have 0.4. So this is the width. Whatever we want, we can choose. So I choose to be 0.3. So 0.3 is good. Now we are having the size of our figure. So it's 8 inches by 6. So I would say 6 by 4. So it's a bit smaller now. Okay, so it's easier to see in the monitor. So now we discussed the figure size as well. Now we need to have the bar function. So in order to have the bar function, we were having the x here, the x-axis, let's say, the y-axis, the width we are adding here. This is the width of our bars. We are having the label, we are having the color, and we are having the edge color. So edge color is black. And what is happening here? So for the first data set, which is this one, we are having x minus width divided by 2. And for the second one, we are having x plus width divided by 2. But why do we need to have that? Let me remove this one so we see the difference. So when I run, we see that we are having overlaps. So these bar charts, the bars that are blue, you see that they are overlapping because A is in the middle now. Okay, so A is the starting point of the orange because we are still having the plus width divided by 2, but A is having the overlap, so, and it's not very nice to have them like that. Okay, so if I also, let me put it here, so if I also remove this part and I run the code, we see that we are having the full overlap. So this is another way to have the bar charts, but this is not what we were looking for now. So in order to make them nice, you see that they are overlapping fully here. We want to have the second data set to move a bit to the right and the first data set, which is the blue one, to move a bit to the left. So the orange one a bit to the right, the blue one a bit to the left, and this happens to all of them. So this orange a bit to the right and this blue a bit to the left. In order to do that, we calculate the half of the width. So this is the width, okay? This is the width and this is the center point. We are going to shift the orange one half of the width to the right and shift the blue one half of the width to the left. So they will be next to each other exactly. I will say it one more time. So I'm going to shift the orange one as large as half of the width to the right and half of the width to the left for the blue bars. Why? Because this way we are going to have them next to each other instead of both being this to the center. So it's like the center of the blue will be this point and the center of the orange will be this point. Okay? So this is the ending part of the blue and the starting point of the orange. So this is why we need to have them here. So when I run, you see that, okay, so A is the center still, but it's the ending point of the blue and the starting point of the orange. So the blue has shifted half of the width to the left and the orange has shifted half of the width to the right. So this is how actually we can make them nice and clear. But we could also have the overlap version if you prefer, of course. So this is the bar chart for the first data set. We shift the first bar chart a bit to the left and the second bar a bit to the right for the second data set, let's say. And this one, again, we are having the X, the values, the width, it's the same. The label is data set 2 and the color is salmon. So you see the color is salmon and not orange, let's say. I didn't realize that it's salmon. To me, they are both the same, but their name at least is different. Then we are having the edge color, and this one is also black. Okay. So then we are having the set category names on x-axis. Here we are having B, C, D, and E. Okay. So we are using this x ticks function to have the x-axis to have the name of our categories A, B, C, D, E. Then we are having the group bar chart, the title, the font size, and we want it to be bold. Then we are having the X label, which is this category, and the values. Okay. And we are having, of course, the legend because we were having the labels here. We want to show the legend here. So this is the legend that we are seeing here. And finally, we are having the show function in order to display our grouped bar chart. So the only thing that we need to be careful is how we are managing this X part. And also, if we want to have the names on X axis, we simply use the X ticks and we are writing down the X axis and then categories to be printed there. So this is how we can have a very nice grouped bar chart. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about stacked bar chart. What is a stacked bar chart? We are having two data sets, dataset 1 and dataset 2. Dataset 1 is shown in blue and dataset 2 is shown in, let's say, reddish orange, something like this. So we see that the dataset 1, for example, for category A, we are having here, the value is 10. For dataset 2, the value is 5. So for the dataset 1, the value of category A is 10. For the dataset 2, the value of category A is 5. So let's go back there. So in a stacked bar chart, we are going to have the category A. So for the first dataset, the value was 10. So the starting point is here and the ending point is at 10 because the value for category A in dataset 1 is 10. However, in the second dataset, the value was 5. But here we are going to start from here. So the starting point of the second dataset is the ending point of the first dataset. Okay, so we are going to start here and we are going to finish at 15 because the value is 5. So 10 plus 5, it will be 15 here. Okay, so this is what we call stacked bar chart. When one dataset starts at the end of the first dataset, the previous dataset, let's say. The same goes with the other categories as well. So D, for example, the starting point is 0 and the value is 30 because it finishes at 30. However, we see that for the second dataset, it starts at 30 and finishes, I think, at 55, yes? So the second data set, we are having D. So D here is 25. Yes, exactly. So it starts at 30, it finishes at 55. So 55 minus 30, it will be 25, which is the value of the category D in the second data set. This is how a stack bar chart would work. So how we can illustrate that? We import the necessary libraries first of all. Then we are having the categories, we are having the first data set, and we are having the second data set. For example, for the category C, in the first data set, we are having the value of 15, but in the second data set, we are having the value of 10. Then we are having the figure size to be 6 inches by 4 inches. So this is the size. I think it's a good size for showing it in my, for example, monitor. Then we are going to have our bar function to plot the bar charts. First, we are having the categories and value 1 and categories and value 2 for the first bar chart and the second bar chart for the, let's say, the bars for the first data set, let's say, and the bars for the second data set. So here is category and values 1 for the first dataset, and then categories and values 2 for the second dataset. Here we label dataset 1, we consider the color and then the edge color because they're black, so we consider it to be black. Here we are also labeling it, we are having the color and we are having the edge color as well. However, we are having this as well. So this part of the code is mentioning that the bottom part, the bottom point of the second data set should be equal to value 1. It means that it should start at the end of value 1. Okay. So instead of starting from here, from the x-axis, it is going to start from where we are having the value 1. And what is the value 1? Here is it. It is. So for example, for category A, the value 1 starts from 0 and it goes up to 10 because the value is 10. And now this 10, which is the value 1, is the starting point for the second dataset. So this 10 is the starting point for the second dataset, as you see here. Okay. So we are having the bottom to be value 1. And value 1, these are the values 1 for each category. For example, for the B, when we want to plot the second dataset, the value for the dataset 2 for category B is 15. Okay, but we are saying the bottom line, the starting point should be equal to value 1, which is 20. Its corresponding values 1, which is 20. So for category B, we have the value 15 and its starting point is 20. So B, the starting point for the data set 2 is 20, and from there we are going to have 15 units. So 20 is here, and we are going up 15 units, which will be 35. So this is how we can have the stacked bar chart. Then we are having the title, we are having the font size, and we're going to make it bold. So we are having the title and the font size is 14, and we are having it bold. And here we are labeling the X and Y axis. We are having the legend being displayed, this part, because we labeled our, plots, our data sets, let's say. And finally, to display the figure, we are having the show function. It was how to draw a stacked bar chart in Python using Matplotlib library. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about histograms. Here is my histogram. This is a basic example of histogram in Python using Matplotlib library. We see that we are having beans here, okay? And this is the frequency. And to generate values, we use the normal distribution. That is why you see the bell shape here. And how can we plot this histogram? First of all, we need to include the libraries, as always. Then we are going to have generating the random data. So this is my data variable. We are going to randomly generate values and 1,000 random values, let's say. And we are going to use the normal distribution. So rand n means that normal distribution. We are going to have standard normal distribution that is going to generate 1,000 numbers for us, okay, and assign it to data. Here is my size of the figure. So I have it 6 by 4 because it's easy to see it here. Maybe even we could make it smaller if you want, 5 by 3, let's say. Okay, now it's even better. So you can have your scale here. Then in order to build the histogram, we are going to have the hist function, HIST. So we are going to use this function. First, we are going to have the data that we generated for 1,000 random values from a standard normal distribution. Then we are having the beans equal to 30. What does it mean? Beans means the units that we are having in the x-axis. Okay, so we are having 30 units here, 1, 2, 3, 4, 5, 6, 7, etc. Until the end, it will be 30. So we are going to have 30 beans here. Okay, then we are going to choose the color. We are going to have the edge color. So the edge colors are black, and the color is sky blue, which is a very nice color, by the way. And that's it. We can have our histogram. Now let's have a title. Basic histogram example. This is my title, font size 14, and it's bold. Then we are having the x-axis label, y-axis label, and we are showing it and we are displaying it. So when I run the code, we see exactly here what we have explained. So this is a histogram, and we are having 30 beans here, and this is our frequency. For example, number for this 0 part, we are having a lot of frequency. For value, for example, -2, let's say, we are having lower amount of frequency because it's like a bell shape, because we used a standard normal distribution using the rand n function. Thank you for watching. Hello and welcome. In today's video, we're going to learn how to plot a cumulative histogram. This is my cumulative histogram here. We're going to learn how to plot this in Python using Matplotlib library. First of all, we need to import the Matplot and NumPy. We're going to generate 1,000 random values from a standard normal distribution. And then we are going to have the hist function to plot our histogram. Then we are going to use the data. We are going to use the beans. We are going to choose 30 beans here. Then we are going to have the color, which is navy, edge color to be black, then the transparency adjustment, which is 0.7, and in the end, we can have the cumulative keyword equals true. When we are having the cumulative keyword equals true, we are going to have our cumulative histogram. So if I want to not to have a cumulative histogram, we can simply remove this keyword and we will see that we are going to have a normal histogram. But if we are looking for a cumulative histogram, this keyword will be helpful to be assigned to true in the hist function when we are building our plot, and we see that this is a cumulative histogram. And this is again our title, x-axis label, and y-axis label. Thank you for watching. Welcome back. In today's video, we are going to learn how to draw a basic pie chart in Matplotlib, okay, using Matplotlib library. So in order to do that, first of all, we're going to import the library that is necessary for plotting, which is Matplotlib library. Then we are going to discuss the sizes representing the portion of the whole, okay? And also the sections. These are the sections that we have. For example, A, B, C, and D. These are our sections. And for example, we are saying that section A has 30% of the portion. So this is the 30%, the blue part. We say that, for example, section D has 15%. Section D is the red part. So it has the 15% of the whole portion. This is how we need to have the sections, or let's say label for each section, and values representing the portion of the whole. Okay. Then, as always, we are going to discuss the size of our figure here. The size of our figure is here. So we are having a figure 4 by 4. And finally, to plot our pie chart, we are going to have the PIE function. Then we need two arguments here. Sizes, which are the portions, the values representing the portions of the whole, and the labels. So the labels that we want to give to each portion, okay? And we name it to be sections. So sections are assigned to the labels. It means that we're going to have A, B, C, and D. So instead of having the sections, if I write down something like 1, 2, 3, and 4, here we see that 1, 2, 3, and 4 are the labels for our sections. But we don't want to have that. We defined sections because we want the labeling to be A, B, C, and D. Instead of writing it A, B, C, and D here, we could directly also write it here. We could say, for example, A, B, C, and D. So if I run the code, we see the same results. But it's easier to define these labels in a section separately here, and then assign the variable name simply here. It's much easier. It improves the coding readability. We define the labels here separately. Then we are going to assign the sections to our labels here. Okay. Finally, we are having the title of the figure saying that basic pie chart example. We are having the font size and we are having the font weight, which is bold here. And finally, we are using the show function to plot and display our pie chart. Thank you for watching.
Hi, welcome back. In today's video, we are going to learn how to have a donut chart. So there is a empty circle in the middle, but how can we draw this? Here is our previous example again. We see that we are having the sizes, sections, colors, and the explode. Here we are not using the explode anymore, so I'm going to remove this part. Then we are having the pie chart here. So here the pie chart is what it's trying to do is the following. So it is going to have the sizes, the labels, and the colors. Then we are having the edge color, which is black. And then we are having the line width, which is 1.5. Okay. Then, because we want to have a white circle in the middle to create a donut chart here, we need to include a GCA. Then we are having the add artist function. We are having to add a circle, and this is the radius. For example, we can modify this, and this is the color. So the color is white. I could say the color to be, for example, black. So when I run the code, you see the middle circle is now black. We can change to whatever we want. So it's white again, and I can modify this number as well. So I can have 0 instead of 0.5, I'm having 0.9. So you see that it's much bigger, and it doesn't make sense to have it this big. We can try 0.3. We see that it's very small now. So I think 0.5 would be a good start to have it here for the size of the middle circle. Also, we are mentioning that we want to have our circle in the middle here. You see that because we are having 0 and 0, this is in the middle. But we can modify this number as well. So if we want it to be middle, we are going to choose the 0 and 0, but we can choose, for example, 0.5, so it's a bit to the right. We can have negative 0.5 here, it will be a bit to the left. Then we can also modify this, for example, 0.2, so it's going to go a bit up because it's the y-axis. So this is the x-axis and this one is the y-axis, and we can go, for example, 0.5, so it will go up here. So it's the x-axis, it's minus 0.5, so it is coming to the left. Then it is going to the up because we are having the positive 0.5. But if I make it negative, it will go down along the y-axis. You see here, it becomes here, it comes here. So depending on what we want to do here, we are going to choose also the x and y. But for the moment, I would like to keep it at the center because I would like to have a donut chart here, a donut chart. So basically in this video, we learned how we can have the middle circle. We chose the color, we chose the size, we chose the center where the center of this circle should be. And in order to do that, we use the circle function to have it being plotted here. But we should remember that we call the GCA and also add artist functions before adding the circle. So if it's hard for you to remember all of these keywords, it's not mandatory for you to remember it. You can just simply copy paste my code and then use it whenever you want and modify it accordingly. So you can, whenever you want, you can check out this code and copy this part or write it down somewhere and then paste it in your project, and you will see the output will be like this. Thank you for watching.